these sort of problems seem like I'm never going to stand in my closet and think about this, but what it actually relates to is decision-making out in the real world. We just pose it in an easier manner so that you guys can make sense of it right now before the situation turns into something super complicated, multi-layered, and like the reasonings to not go to the casino and spend your life savings. A math problem that I can use for the rest of forever, but I lost an amount of Kit Kats. It was supposed to be a bag, but there was no bag of Kit Kats in existence. So I bought her like a king size and a package. Whoa, to each their own. Let's not judge each other's candy preferences. This type of problem of how many options are there comes from a branch of math called combinatorics. Grab a Chromebook, either from Goldring's room or if you have your own. So combinatorics asks how many combinations, right? So here, combinations, different outfits. Always wears a shirt, pants, socks, and shoes. So he always wears 4 different things. And guys, this is when you should never argue with your parents about like, but I don't have anything to wear. You do. Because if you have 12 pairs of socks, when I go and put on my socks, that means I have 12 different outfits. I know this is going to be funny. If I only wear socks. If maybe it's your birthday, you run around doing your own thing. I don't know, we had a family that came through Phoenix that apparently didn't like to wear clothes when they were at home and whatever.
What?
Look, people tell us some weird things. So, if I only wear socks, right, trying to get some breeze, 12 different outfits, but that's inappropriate. So, your parents tell you to go put on more clothes, and you're like, fine, I'll put on shoes, and they're like, that's not what I meant. But if you have 3 pairs of shoes, now, with the combinations of socks and shoes, you can actually make 36 different, although inappropriate because you need more clothes on, outfits. When you decide you'll give in to societal pressure and put on some pants, you should wear pants. And not long pants, but I mean like something, right? So your parents are like, look, go put on pants. So you go put on pants, and that actually gives you 5 more options. But when we talk about that, that actually multiplies. So it's not like you're adding 5 options, you're actually multiplying. 150 plus 30, 180, I think. And the final thing you do is because you're trying to go to the convenience store and buy a soda, you're also going to need a shirt. And now we could add to this, how many masks do you have to choose? So then 5 more, right? So times 5 again. And we have notes about that. The notes called it the fundamental counting principle. And what I said in the notes, literally, and asked you to highlight, was just multiply. Anybody else want to hop in my Zoom? Right, so these numbers are not super nice with each other. We're being asked to figure out a new... Wait, crap. Yeah, no, here it works. Other problems, they go backwards, which means if we go from B to A, that's quote-unquote backwards, like how we think. Natalie, is this one yours? Is this one yours? Was this your screen share? I saw you enter the Zoom. I didn't know if this was you or me or... Okay. This is you? Okay. Did you make your name, Natalie?
No, it said name.
Maybe my brain just changed it. Sorry, so our scale factor going from 45 to 35 is what we're looking for. We always do new... Oh, wait, no paper? Okay, I guess we don't want to do math. Because we're at that point in the year. If you don't want to do math, I'm not going to do math. So when we talk about scale factor, if we went back to check our notes, we always kind of call it new over old. It doesn't really matter. We could do old over new, but new over old is normally nicer to think about. Like now I have this where I used to have that. Write that down. Now, really, what we look at for new and old is we're always trying to go to the x. We always want x to be our new. So, Nate, here that tells us to do b over a, because x is part of shape b. You see what I'm talking about? So, we're going to do the b value over the a value. So, what b value and a value do I know that correspond with each other? That 45 and 35, right? But the new one is what we want to put on top. So we're going to do 35 over 45. Did you write that down?
Yeah.
It doesn't matter now. Get your hand off the mouse. You don't need that. Pick your pencil up. What do we put on the other side of this fraction that comes from what I had circled in purple? Tell me if you can't see the screen because of glare or whatever. So remember, things have to agree. If 35 is on top in the first fraction, x is going to go on top in the second fraction because these are from the same shape. Does that make sense? So those correspond with each other, but also x corresponds with from the original shape. What number from the original shape? What goes on bottom? That goes with x. So we said that 45 and 35 go together because they're like the same side. Yeah, so the 27 and the x are going to go together because they're like the same side. We called that corresponding when we did that in class. So now the method that we said always works. We could always cross multiply, or Nate, what we've been doing a ton of, if we don't know how to multiply, we divide. So, calculator right here, or the one on your computer, but you know what you normally need to grab when you come into class. These calculators are going to be easier to work with, I'm telling you. They should be clean from yesterday, but that's up to you. I was just picking those up to see if I needed help. So Nate, do you got a calculator now?
Yeah.
So we're going to do the division 27 divided by 45 and use that to get our new value. So what we're saying, Nate, is to go from A to B. This is times 0.6. So that's what we do up here. Okay, we do times 0.6. Wait, that doesn't work. Because this is not set up the same as this. Right? That's the problem. If we wrote out work, we got to make sure we use that. So we could do that over here, but this will be different. That will not be 0.6. So be careful. Come to the work we wrote. Do 35 times 0.6. Is it? Sweet. Alright, sorry, I'm going to assign some stuff for those of you that are sitting and waiting. Now that, or you can also help your classmates, but the reason I worry about that is I don't want you giving answers to people. What due date should I code these under so that you know they're not like required?
October 27th.
No, I think it needs to be sometime soon, before the end of May, probably.
May 1st. May 23rd. That's when.
So, because the competition... Alright, so whenever we look at these problems, I'm always starting with just thinking about what it is that we want or what is favorable here. This is not my statement. This is like Khan's question. We want boys here, right? Now, my brother just had a boy, and I think they wanted a boy. But here we're talking about the probability of getting a boy. Probability of getting a boy out of what situation? Well, let's look. Mrs. Avery is going to randomly select one student from her class. There are 15 boys, 13 girls, and we always put what we want over the total, and that's gravity. That's the trap door here, the total, because they don't give it to us. If you do 15 over 13, that's wrong. If you do 13 over 15, that's wrong. It's 15 over, we got to add them up. We get 28. So it's always what we want over the total of what we have. Does that make sense? All right, so with this one, yeah, you're good. Sorry, you guys don't really ever have to ask me. So we have data from our sample, and yesterday we talked about we use our sample to then predict the real stuff. So here hockey has 10 out of, I think we got to add up to figure out our total. Sometimes they tell us our total from our sample. I don't think. So 15, 9, 10 we already said, 8, and 3. Yeah, that sounds more right. So, 10 out of how many? 45. And then that 414 they gave us, would that go on top or bottom of the other fraction? Yeah, because it's total, right? And we said we try to figure out how we go from here to here. And if it's not nice, right, if the multiplication's not nice, we divide it backwards. Yep. So the work we do in our calculator is 414 divided by 45. That tells us the multiplying factor, which is like 9 point something. Oh, I guess that's kind of nice. Yep. So we do the same multiplication on top. I think so, yeah. Yeah, I'm like pretty sure it's 92. Wow. All right.
Okay, so.
What is the 21?
The 21 are like people who expect to go on duty.
Yeah, the 3 is a distractor. That's not a number we care about. It's just the thing we want, right? It's telling us what is favorable. So that 21, that is what you want, quote unquote. What was your total?
45. And then the total score is 5.
There you go. 48.
The only reason I asked is so that I don't get started on something that
I think you might like me better than Miss Allie. It's okay. You don't hurt my feelings. And I'm still going to be here next year, so there's that. There. When it says find the area, what my brain says is, I know the area formula. Area is pi times radius squared. And I write it down because I get excited that I know it. Dude, do you need a piece of graph paper? I will hand deliver it to you. No postage necessary. Yeah, see, that's what I was about to say. The handling fee is extra. I was like, what are they doing with the handling fee?
I just
Like-
make sure they don't throw it.
But then they
See, I was gonna say
do!
they still throw it.
UPS walks up and they're like, I bet you I can land this on the porch from back here.
I think a package that has a frisbee in it.
I saw this video, and it's like only funny because it's like kind of funny when you can laugh at yourself. The dude like just walks up and just like dumps the box on the ground, but then turns around and trips over himself and the box and just falls on the ground. It's like, well, pay attention to what you're doing. They then give us circumference, and I remember the circumference formula: crust is pi dough. That was the memory trick that we used, right? Crust is pi dough. And it's true. Crust is the crust of the pie. It's pie dough. So we fill in the 12.56 in C because that's what they told us. Is there anything else up here that I know, Aiden? Do I know any other? Yeah, but that's just part of our label for our answer. In the formula for circumference, that circumference equals pi times diameter, is there any other number that I know up there that I could like?
3.14.
Pi. So, could I get diameter by itself now?
Yeah.
What do we do?
We multiply 3.14.
That's what it wants us to do, but we can't. So what's the opposite of multiplication? We divide by 3.14. Remember, this makes a giant 1. Should switch. Oh, I can't use both of those cameras at the same time. Crud. I don't have enough cameras, surprisingly. Alright, so when we do it on both sides, I think you should get 4. What is that, though? The 4 is the... So this turned into a 1. So essentially, it's gone. What do we still have on the right-hand side?
The diameter.
So diameter equals 4. How do you get the radius if you have the diameter?
We divide by 10 for this one.
Yeah, because That means our circle's 4 wide, right? The circumference. Is it that? Sorry, diameter. That diameter's not drawn in quite the right place, but then we could draw the radius of 2. Not quite drawn correctly, but close. So, Miss Meyer, I need to send a staff email to ask how we think this would work best. We have 5 gallons of waterproofer, and we have 50 paintbrushes. Or actually 60, I think. Math is hard. But I don't want kids to get waterproofer all over their clothes. Ooh, I don't know if we have smocks of some sort, but that's a really good idea. Like, if we could trust them to not, like, splatter each other, like, if only a couple kids did a table at a time and they were just super careful, I feel like it might work, but you have a really good point. Like, bring in an apron or a smock or something.
Put just 4 or 4 equals D.
So, neither. Because what are we trying to solve here?
The area. So,
We found out the radius was,
2.
so 2 squared, then times pi. Weirdly enough here, you get the same answer.
So it just gives us an answer.
This is the one circle where your circumference and your area are the same number. They're not the same. Remember, one is like a string and the other one's like paint, right? So one is length and the other's area. Make sense?
Yeah.
So this is that weird circle where the numbers come out to seem like they're the same. And they are the same number, but they represent 2 different things.
I just want to check my answer.
Should I put R after?
So hey, make sure you're writing this down. We did this. You plugged in your radius of 2 and squared it. Pi then multiplied by it, and we got, that's it. But our label is units squared, because it's area. Does that make sense? So there's nothing else to put in with our answer. We're just looking for that number. 11 1/4 happens. Scroll up so I can see the prompt, Adam. Yep, that sure looks right.
But there's a second part to it.
How is that?
So how could we check if 6 hot dogs per minute will break it?
Instead of 90, we put 60.
What would 6 take the place of? Alright. I don't know whose screen I'm looking at, but with a radius of 7, are we doing area or circumference? Area. Guarantee that is not correct. So let me copy this out real quick. Do not hit check. Please do not hit check. You will get it incorrect. What's our area formula?
Area equals 5 times radius squared.
Yeah. Now, what does squaring the radius do? Because I think I know what mistake you made.
What times like 7 times 7?
Yeah, well, what is 7 times 7?
49.
So this is really pi times 49. I think the answer you typed in was less than 49. This is definitely going to get bigger than 49.
I just did the A equals pi times diameter.
That's for circumference. You're mixing up your formulas. They ask us for area, right? So you mixed up which formula goes with which thing. That's circumference. So they tell us to put our answer in terms of pi. This number is a pi number because it has pi in it. But we like to write it with the 49 first. So our answer is 49 pi, which really means 49 times pi, but we don't have to put the multiplication. So what you're going to type into your box is actually 49 pi. And then pi will switch to the pi symbol, and that represents 49 times pi. So you can either click on pi if they have it as a, they have it as a symbol there, so you can click on it. And there you go. That's it. We square the radius, multiply by pi. Alright, so she gives 1/3 of a sheet to each of 45 students.
So she loses a third.
For every student, right?
Yeah.
And she does that 45 times. What's a third of 45? Well, what would 45 divided by 3 be?
15.
Yeah! So the 15 that is in each of those multiple choice problems, that comes from how many stickers she gave away to her friends, right, to students. Then what does she do? Because she keeps giving them away.
Wait, how do I know who the teachers are?
We don't. What do we know?
How many stickers that she would have left?
What else do we know?
She wants to give the teachers 1.5.
So if each teacher is getting 1.5, is there another way to say 1 1/2?
1.5.
Is there another way? Look at the answer choices.
3 halves.
3, okay. So 3 halves, so I get 3 halves, Miss Myers gets 3 halves. Like, okay, so we don't know how many teachers she's going to get to give stickers to, but she just keeps doing this. So she gave away 15 to her friends, and she's giving 3 halves to every teacher she finds. So this is what she's giving away. Can she give away over 21? No, that doesn't make sense. What is she able to give away?
Less than or equal to?
So which one is that?
8.
There you go.
But there is a second part too.
I know, you gotta solve it.
Oh, okay.
So then you solve it. I would leave things as fractions. Here's the thing I'm gonna help you with though. When you get to 3 halves t is less than or equal to something, there's gonna be a number over here, right? There'll be some number. We'll draw a hashtag there too. Do you know how to get rid of 3 halves? Do you remember what we do?
You just
Say it's gonna be multiplication.
what?
Uh-huh. What number on top could wipe out our number on bottom? If we want to wipe out this 2 on bottom, what can we put on top? A 2. If we want to wipe out this 3 on top.
3.
So we multiply both sides by the reciprocal of the fraction we want to get rid of. Because now this all wipes out. It really becomes 6 over 6. 6 over 6 is 1. All right, so go ahead and take a moment to solve it. I know you got to do a step before you get to that step.
Which is equal to 13.
Yep.
Let me check this problem.
That is not correct. I'd like you to double check your work before I guide you. Check your formula, check if you were using the right values, like measurements of the circle. I know exactly what you did. So if you can't figure it out, let me know and I will tell you. But it's a trap door. You fell in a trap. No. What do they give us? What do they tell us in this problem, Aiden?
The diameter is 16.
And what do we want to use to find the area?
Radius.
The radius. If the diameter is 16, what is the radius? Ah. So we do 8 squared and then times pi, which we can just write the number we get times pi.